Alright, hello. I was going to just go over this in class next week, but I figured me going over this in a video would probably be good because you do have the quiz coming up. So let's look at the problem as we had it. And remember, all these things that we're looking for, what are we going to have to worry about? We're going to have to worry about the decision variables. We're going to look at the objective function. And we're going to worry about the constraints. And actually what we can do before that is we can fill this in. Just a quick point, I did quickly clean up the sheet to make it kind of standard in with the book because I know this was a last minute draw in and it wasn't set up the best way it could be. So I changed the colors. I actually removed the one line because I used to have it set for 5 pounds and I've gotten rid of that. And I also flicked around the constraints. So if you want, you can go grab this new sheet off the Sakai website and it's there. And so let's just go through this. I'm going to put the inputs in first and then we'll hit these. So the steel, the margin on the steel was 40 cents per pound on the sheeting. The aluminum was 60 cents per pound. The contribution sale on the standard chassis was $12 per chassis rack. The deluxe was $15. And the standard chassis said that it uses 8 pounds of aluminum, 16 pounds of steel, and the deluxe chassis uses 12 pounds of aluminum, 12 pounds of steel. And it gave us an assembly time in minutes of 24 for the standard rack, 36 for the deluxe. And the last input number they gave us is they think that they will sell no more than 1,200 standard racks and no more than 1,000 deluxe racks. So there is all of our inputs. So what are our decision variables in this problem? So we do have 4 of them because the first one is we can say how many pounds of steel that we're going to make into sheeting. So X1 would be pounds of steel sheet. X2 would be our aluminum sheet. So we've got these pounds of aluminum sheet. So we have these 2 different set types of sheetings that we can make, and then our third one would be the number of standard racks that we can make. So number of standard racks, and finally the last thing that we have is our number of deluxe racks. Number of deluxe racks. So these are decision variables. This is what we get to pick, what we get to say, what we get to drive. Now, so we have our objective function. So what is our objective? Our objective is to make the most amount of money possible, the most profit. So we are going to be maximizing a function, and so what are we going to be maximizing? We're going to be maximizing the number of steel sheets that we have times the amount of steel sheet, so that would be X1 times 40 cents a pound, plus the amount of aluminum sheet, so X2 times 60 cents for each pound of aluminum sheeting. We are going to have our X3, which is the number of standard racks, and so each standard rack is going to bring us in $12. And then finally we'll add to that X4, which is our deluxe racks, and each deluxe rack is going to bring us in $15. And so that is the function that we are trying to maximize. Now, we're going to be maximizing that subject to a couple of constraints. And so we look through the problem, and one of the first constraints is that we can polish no more than 4,000 pounds of metal sheeting in the next period. There is no metal sheeting used in either of these. The metal sheeting is just making the metal turning into sheeting. So that would be the amount of steel sheeting that we have plus the amount of aluminum sheeting that we have has to be less than or equal to 4,000. So we can only polish up to 4,000 pounds of stuff. So there we go, 4,000 pounds of stuff. Well, the next thing is they talk about stamping out the chassis. So the manufacturer can, they said, and the problem, the chassis manufacturer can be restricted either by the metal stamping or the assembly operations. So on the metal stamping, they say that no more than 2,500 total chassis can be stamped. So the sheeting has nothing to do with that. We are just looking at the chassis. So X3, which is our standard chassis, plus X4 has to be less than or equal to 2,500. The other one that they give us is the assembly time. And so they say we've got 24 minutes for a standard, 36 minutes for a deluxe, and then we are told that they have 920 hours of time. Minutes, hours, we have to unify that to make that work out. So why don't we'll leave it as minutes, so we'll say 24 times X3, which is our standard chassis, plus 36 times our deluxe chassis, which is X4, has to be less than or equal to whatever 920 times 60 is. Let's just do a quick calculation. 920 times 60, done. So 55,200. We'll just drop that in there. 55,200. All right. And so the next constraint we have is actually information that was given to us very first in the problem is how much material that we have. Now this is the one that gets a little bit tricky because we have to kind of think about it. So for steel, I have the steel that I use in the standard chassis, I have the steel that I use in the deluxe chassis, and I have the steel that I'm actually turning into sheets. So if we look at this one, this is going to be the pounds of steel sheeting, so X1, and we will add to that 16 pounds times X3, which is our normal chassis, plus 12 pounds times X4, which is our deluxe chassis, and that has to be less than or equal to the 26,000 pounds of unfinished steel that we can have. And then we do the same thing for the aluminum. The aluminum's X2, that's our aluminum sheeting. And then we need 8 pounds for every standard chassis, so 8 times X3, plus 12 pounds for every deluxe chassis. And that has to be that has to be less than or equal to the 20,500 pounds of raw aluminum that's available to us. Now we do have another constraint, and that constraint is the demand. And so we have a demand for the steel chassis, a demand for the aluminum chassis. So the regular, not the steel and the aluminum chassis, I'm sorry, the standard chassis and the deluxe chassis. So standard chassis, X3, has to be less than or equal to 1,200. And then X4, which is our deluxe chassis, has to be less than or equal to 1,000. And then we can throw in non-negativity constraints. So X1, X2, X3, X4 has to be less than or equal to, well, greater than or equal to 0, because it can't go below that. So there's a lot going on in this problem. This problem is much more difficult than what the quiz is going to be. But now that we have that, now it just comes to coding this in Excel. So we go to profit. What's our profit going to be? Well, I'm going to use a sum product, and I'm going to sum product the margin on our sheets along with our sheet amounts. Actually, let me go back here and make some range names for all this. Okay, we'll highlight all of that. Formulas, create from selection, left column. Now let's throw the profit in there. And then from here, I'm holding control as I do this so we can get all of these in there. Create from selection, top row, And then we'll come over here, range names. Using formula, paste names, paste list, and there we go. So we have a lot going on here. So let's go back to the profit here. And some product, our margins per pound of sheeting with our sheet amounts in pounds. Now we also have to add to that, we have some, we have our profit from the chassis. So the contribution to sale on the chassis and the build amount of the chassis. That's why I have them different names, so when we do the range names, they work out. And so let's just put one of each in there just to have it work out. Okay, so actual polish, polish max. Well, our maximum polish is 4,000. Our stamping max from our problem is 2,500. Our max assembly time is 55,200 minutes. We have 26,000 pounds of steel available and 20,500 pounds of aluminum available. So we go through here and we just look through the constraints that we made, x1 plus x2, so we're going to sum up the amount of sheets that we're going to make. Chassis stamping, we're going to sum up the amount of chassis that we're going to make. Assembly time, so assembly time, we're going to do a sum product of how many chassis that we build with its assembly time in minutes. And then finally, steel. Well, how much steel are we going to use? Well, I have the steel that I'm using from the chassis, so steel needed with the build amount of the chassis. But I also have to add to that how many steel sheets that I'm making. And then we're going to do the same thing for aluminum. So sum product, the amount of chassis that we're going to make with how much aluminum is needed. And then from there, I will add on the amount of aluminum. So now all of my constraint equations are done. My profit equation is in there. My decision variables are connected to both my constraints, connected to my profit. So if I sit here and I change things, I can see that if I set everything to 0, everything goes to 0, is what I expect it to do. Now from here, everything is set up. I'm going to end the video here. I'm going to do the next video where I'm just going to quickly go through Solver, and then we should be good to go. If you have any questions, remember, please let me know. Otherwise, I will see you in the next video.